My name is Matthew Lichtenberger. I'm a senior cyber intelligence analyst at this UPS Security Operations Center here in Louisville, Kentucky. Today, I'm going to demo a new way of surreptitiously transmitting data that I call PacketKO, short for Packet Knockout. We'll first go over the implications of data exfiltration, their context in relation to data breaches that have occurred over the past decade, and how PacketKO enables another method for bypassing monitoring channels when communicating outbound. At the end, I'll be happy to answer any questions or run additional demonstrations if specific use cases are provided. So data exfiltration is widely defined as the means by which data breaches occur, whether it's communicating over common service ports to remote sites that aren't running their respective services, or transmitting data via FTP in the clear, or even utilizing so-called sneaker net to carry a USB device chock full of sensitive corporate data. An exfiltration of data means a lot of pain is incoming for the company unfortunate enough to be targeted. The implications are even more dire when privacy laws, such as HIPAA or FERPA here in the US, as well as other measures enacted in other countries, are factored into the equation. The result is very costly, with months of workforce time and millions of dollars spent investigating the exfiltration, fixing the access, sending out notifications, reissuing information, and reassuring the public. Even then, the damage to the company reputation may persist for years, and some leaked information has no remediation available. On to the data breaches. Over the past decade, a myriad of data breaches have hit major companies and organizations, including Target, credit cards, Home Depot, credit cards again, or OPM, personal and classified data. A technical understanding of how these breaches occurred isn't necessary. It will suffice it to know that in each breach, the commonality was the exfiltration occurred utilizing standard network communication, mixed in with the normal day-to-day traffic going out. This sort of hiding in plain sight is extremely difficult to pick out. And unfortunately, the industry has trended towards studying deeper, developing deep packet inspection tools to try and identify the content of each packet for potential violations. Unfortunately, by focusing so narrowly, context is lost, and the hypothetical analyst is left trying to find the forest amidst the trees. So a quick primer on port knocking. Port knocking is a technique that is familiar to some in the IT community, but its use has never graduated beyond that of a clever hack. So a quick primer is worthwhile. Essentially, by monitoring the drop packets on a firewall, a port knocking aware program can turn the firewall into a sort of a magic door, where a prearranged secret knock or a set of packets set to closed ports indicates that the authorized user is trying to connect. The program can then instruct the firewall to open a single port, a range of ports, or the entire span to the specific incoming IP address for a set period of time. Traditionally, this has been done to allow easy access to remote internal resources without appearing open to the myriad scanners operating against internet-facing addresses. The primary weakness to this technique is that an attacker on the same network as the client could see the same transaction and do their own knock, pretending to have legitimate access. So PacketKO is a pair of Python scripts designed to demonstrate the inherent means of data exfiltration via port numbers. Utilizing these scripts, you can set up a server using exfild.py and have the client transmit the data to it unidirectionally. The transmission is prone to errors, as the tool utilizes UDP packets, and thus there is no guarantee of delivery. However, a benefit of this utilization is that the receiving server has plausible deniability, as the system relies on the logging features of IP tables and rsyslog. No listener is actually established on the remote server, and thus, if someone were to investigate, they might conclude that the packets must have been dropped. The scripts support multiple methods of obfuscation. Additionally, the payload in the packet is a randomly generated set of 0 to 50 hexadecimal bytes. The tools provide options to enable base 16, base 32, or base 64 encoding, also useful for transmitting binary data as ASCII. They can set an arbitrary delay between packets being sent and support offsetting the port numbers by a static amount. Additionally, the server side handles multiple items that previously were large pain points. If provided with root and the relevant command line option, it will create the IP tables rules and rsyslog configurations necessary for its operation, If not, it will suggest to the user the kinds of modifications that need to be made based on the encoding and offset specified. The only major caveat here is that the program needs to be terminated with Control-C in order to clean out the IP tables rules. If it terminates unexpectedly, you will need to go in and manually remove the logging rule. Finally, the server side will multiplex connections based on the incoming public address. This allows multiple data payloads to come in at the same time. However, if all of the clients are behind a NAT, you may run into problems, as the incoming address will be the same for each client. Future modifications to this tool aim to enable TCP transmission with single-bit return communication established via reset responses versus acknowledge responses to the initial SYN packet on a given port number. Additionally, a nonlinear transmission system would provide further obfuscation, as the bytes would no longer be in order. Finally, options for more dynamic port offsets are a goal, such that a rotating table of offsets could be utilized, or offsets based on the mathematical properties of each port number. I've posted the complete source of this tool on GitHub, and I'm always open to improvements and suggestions that the community as a whole can make. Feel free to use it and improve it. My only request is that you let me know of improvements you make. I'd be happy to utilize these improvements in future iterations of the tool. So now we're going to go over to the demo. So what I've got is, I've got a remote server over here that's running the Exfil daemon tool. Let me make sure I get it right. So I realize the brightness on this isn't the best, but give me just a second. Let's see what I can do. Here we go. Font. Might be too big. How's that? Better? And then over here, which again, need to get the font. So the server side is running now, and I'm going to go ahead and reissue that command so you can see it as a whole. So each tool comes with a very pronounced help file. So if it explains each tool, each option in the tool, and allows you to set up your rules as you want. So quick overview of the command I'm issuing. I'm instructing it to use base 16. I'm pointing it to the log file /var/log/firewall.log. I'm giving it a static offset to its ports of 2000. I'm sending the termination character as 71, which happens to be the ASCII code for the letter G, which wouldn't be in base 16. I'm giving it attack V for verbose, and then I'm giving it attack F to have it create the IP tables rules and the rsyslog configuration automatically, hence why I need to run it with sudo. So we run it, and it says logging incoming packets. So now we're going to go over to the client side, where we have a test document. That has proprietary information that we might want to send out. Now in this case, I just manually created it, but hey, you know, sky's the limit here. So what we're going to issue is so we start with a delay. In this case, I'm going to use 0.01, which sets the delay between when it sends packets. This allows you to set rules where you can do slow and go, essentially sending packets once every 10 seconds, once every 24 hours, once every week if you wanted to. It can take a while, but then you're going to go under the noise limit on most monitoring tools. We need to match most of the other parameters, so we're going to say base 16. We're going to give it the text file as our file. Again, static offset of 2000. We're going to point it at the remote server, and in this case, that is We're going to give it the same termination character, and then we're going to give it another V just so that we can see in more detail what's going on. So we hit enter. It's sending the string. And if we look over here, we get most of the message. As I mentioned before, this is using UDP. Each packet needs to make it in order for the full and complete decoding. So in some cases, you may not get anything. You may get complete garbage. Playing around with the specific port offsets, playing around with the packet delays, I've found, depending on where I'm sending it from and where I'm sending it to, will result in different results in terms of reliability of packets. But we can still get enough of this that we can tell that this is my secret credit card information that I saved locally. No one will get this. The full credit card, and my password is trust no one. So if we then terminate out, we can see that we have two files created in here. The first is a raw text file of the incoming string, and the second is the parsed message that it ran through. Now, these files will be created for each incoming IP address. As I mentioned before, the server will multiplex connections, so you can receive connections from multiple disparate IP addresses at the same time. Anyone have any questions? Anyone want to see the demo again with some other settings?
Sure.
Okay. So we can also do...
If you were transmitting a encrypted file, it probably wouldn't work very well.
No. In my experience, actually sending binary files and sending encrypted files is lossy. You'd want to go very slow in those contexts, packet delays of at least 10 seconds between each one, but at the same time, it is UDP, so there's a very real chance that you won't get anything. I haven't really come up with a good solution for that, honestly. The TCP idea that I mentioned beforehand is my best suggestion, but I haven't had the time to implement it yet. So, yes?
What does this look like on the wire? So, for example, if you were trying to send the letter A, how many ports would need to be open to get through? Like, is an A 80, port 3, 50, you know?
Well, actually, that's the magic of this. No ports need to be open on the receiving side. This is monitoring, this is setting up an IP tables rule with log for the specific port ranges based on the offset and the fact that A, I think, is ASCII 71 for, or ASCII 56, something like that, for capital A. So I can actually fire up Wireshark and show you what it looks like on the wire if you'd like. I might have to fire up the magnifier because I don't think I can do the magic of okay, there we go. And in this case, I don't even need to set up the receiving end. I can just go ahead and reissue the same command. And if we limit ourselves to UDP only, we can see that right here is where we start seeing these. So we have port 2053, 2052, 2054. So you can see in each case, it's just doing that static 2000 port offset and then adding the ASCII value of the letter that it sent out. And then moving on to the next one. As I mentioned before, one of the other improvements I want to make on this is actually handling a rotating cipher, essentially, of offsets instead of just a static one, because static you can still kind of tell that there's a pattern going on there. But if you're suddenly bouncing 2,000, then 5,000, then 1,200, then 1,500, as long as both the client and the server agree, you could hide it a lot better. So, but in each case, you can see the packets have a static data set 0 to 50 hexadecimal bytes. It's completely random. It's just designed to further throw off the trail because usually empty UDP packets are pretty anomalous. But in this case, the data field of that packet has nothing to do with the data being transmitted. It's all about the receiving port. Any other questions? All right, well, thank you all for your time. I hope this has been very instructive. And as I mentioned before, you can reach me at my email address, which is right there. You can get on me on LinkedIn, or as I mentioned before, this entire project can be found on GitHub, and I'm happy to take suggestions, improvements, anything else you can think of. Thank you all again. Just so I understand.